Hello everyone, this is Navin Kumar. Today my topic is about uh, model analysis of a stepped bar from the subject of finite element and analysis. Here I want to discuss about model analysis. Here the purpose of model analysis. Here the topic is about model analysis. So I want to discuss some of the terminology and the procedure which are involved in the model analysis. So coming to the model analysis, the technique is used to determine the structural vibration and technique, natural frequency, more shapes, and more factors. How much given modes participate in a given direction. The most fundamental of all dynamic analysis types. Here, definition and the benefits of a model analysis allows the design to avoid resonant vibrations or to vibrate at a specified frequency. Speakers, for an example, gives an engineer an idea how to design will respond to different types of dynamic loads, helps in a calculating solution and controls, time steps, etc. for an other dynamic analysis. Recommendation because of structural vibration characteristics determine how it responds to any type of dynamic load. Always perform a model analysis first before trying any other dynamic analysis. The terminology and concepts. Here, mu plus cu plus ku is equal to St. Here, the m is the mass, c is the spring constant, and c is the equation for the vibration. So these are the equations which are used in the model analysis in order to find out the natural frequency of a bar which are going to experience. And here the modified equation assume for a damping, by ignoring the damping and for a free vibrations, the equations can be modified into mu plus ku is equals to zero. Damping the force get uh, removed. Assuming harmonic motion, here u into sine omega t. Omega is the angular rotations, and for a k minus omega square mu is equals to 0. The roots of equation omega square is the eigenvalues where ranges from I1 to 0 number of degrees of freedom corresponding to the values of R and U where the images. Terminology and concepts. The square roots of these eigenvalues and crystal frequencies, radians per second, the natural frequency is found and calculated F1 is equals to omega by 2 pi cycles per second. The natural frequency F1 that are input by user and output by ANSYS represent the mode shapes assumed by the vibrating frequency. The mode of extraction methods. Black allowances and subspace and power dynamics have reduced unsymmetric and damped pull and QR damped. Which method we choose primarily is the most size relatively compared with a particular application. And the black Lancos method is common for the most applications. Efficiency extraction of large number of nodes, particles in most models, typically used in a complex shapes models with mixture of solids, shells, and beams, etc. Efficient extraction of molecules in a frequency range handles rigid body modes well. When extraction of a small number of nodes less than 40 is similar size, the model subspace is much can be more suitable and requires relatively less memory but large disk, disk space. May have a convergence problem when the rigid body modes are present, so not recommended when the constraint equations are present in general black. Damping is normally ignored when the model analysis, but its effects are significant in a damping. So the typical application of a rotor dynamic where gyroscopic damping effects are important. Two antis elements are beam 4 and pipe 16 allows the gyroscopic effect can be specified in the form of constant spin, rotation and speed and real time. Calculations complex and eigenvalues and eigenvectors, imaginary part of natural frequency. Real part indicates the stability and negative means stability and positive means unstable. Here the display shows about the MODP and QR dump mode. When we can click here, we can access that mode. Here the comparison of a superposition performance and QR dump mode extraction. Okay, you can see the uh, damp by CPU is the blue color and EBS is in seconds, which is in dark color. The built-in models, the pro the uh, the procedure for a model analysis. Build the model, choose the analysis and types of options, apply the boundary conditions and solve and review the results. Building the model. Remember density, linear elements of materials only. Non-linearities are ignored. See the modeling consideration. Choose the analysis and types. Here, the preferences are like pre preprocessor analysis and analysis type, new analysis options. Define load setup, or load setup, ops to solve FSI setup model. Choose analysis type and options. Enter the solution and choose a model analysis. Extraction, mode extractions options, mode expansions options, and other options. Mode extractions options method block blancos recommend for the most applications. Number of modes must be specified except reduced method. Frequency range default to entire range but can be limited not to a desired range. FREQB to FREQE. Specification of frequency range requires additional factorization. It is typically faster to simply request the number of modes, which will overlap the design range. Apply boundary displacement constraints. Apply as necessary to simulate the actual fixity. Rigid modes can be actuated in directions to be considered. Non-zero displacements are allowed. For displacement constant, we have taken a plate with a hole with a fully quadrat symmetric type, which is on a 53 mode as a mode measured by an anti-symmetric case because of 40 work is non-zero along the symmetry of boundaries. And here we have the review results like choose results or by pick the general perspective menu. Notice each mode is sorted in a separate substep. Review results. Partification factors calculated for each mode on transaction and rotation directions. High values in a direction indicates that the mode will be excited by the forces in the direction. Values are relative based upon a unit displacement spectrum. The final participation factor value or TOS can be retrieved into the parameters using get command. The spectrum analysis with the specified direction set 0, 1, 0 could be used to obtain other values, also printed out to output file. The effective mass. Ideally, the sum of the effective masses in each direction is equal to the total masses of the structure. Effective mass participation factor. Then thank you.